angular momentum operator problem in spherical polar coordinates. So we are going to achieve the square of angular momentum operator somehow. So to start with, we can use the basic definition of L vector is R cross P, and if we take the operators, then we can use the operator for P as minus IH cross del vector, and we know that del vector in spherical polar coordinates can be written as R cap del over del R plus theta cap 1 by R del over del theta, and this can be written phi cap 1 over R sine theta del by del phi. So this is del, the gradient in spherical polar coordinates, and if we take the cross of R with this, we will get L vector is minus IH cross. The R goes here, it will become 0, the radial part will become 0. The R cap, R will be cancelled out, R cap cross theta cap will be phi cap del by del theta. Then R cap with phi cap will be minus theta cap, R cap, R will be cancelled out and will become 1 by sine theta del over del phi. This is L vector. Now we can plug the phi cap and theta cap here. So from spherical coordinates, we can write, let's say this is Z, this is X, and this is Y. And let's say this is vector R, and this is angle theta, then this will be R cos theta, and the projection here, this will be R sine theta, and as this angle is phi, azimuthal angle is phi, this term will become R sine theta cos phi. So R cap can be written as, I'm taking unit vector here, so it's sine theta cos phi I cap plus sine theta sine of phi j cap plus cos of theta k cap, and we can write theta cap from here, it will be cos theta cos phi I cap plus cos theta sine phi j cap minus sine theta k cap. Similarly, we can write the phi cap, this will be minus of sine phi I cap and plus cos phi j cap. We are getting these two by differentiating this with respect to phi and theta. Now we can plug these values of phi cap and theta cap from here, and this will turn out to be L cap is minus of IH cross, and the phi cap is minus of sine phi plus cos of phi j cap, and there is 1 del by del theta out here, so del by del theta. Now it's minus theta cap, so we are plugging the value of theta cap here. So theta cap is cos theta cos phi I cap plus cos theta sine phi cos theta sine phi cos theta sine phi j cap minus sine theta k cap. So we have plugged in the value of phi cap here, and this term is there, so it's 1 by sine theta del over del phi. So this is angular momentum in ij and k, and now we are going to separate ij and k. So we can see here, so this is I cap, yeah, this is I cap. So Lx, the x component which is of I cap, can be written as, if we take I cap is minus sine phi, here it is cos theta cos phi, so I'm taking minus out of this term, so it will become IH cross. Now this is sine phi, and there is 1 del over del theta. In I am taking the terms of I out here, this will be plus cos theta cos phi, then there is 1 by sine theta del over del phi, so cos over sine will be cot theta, so it's cos phi cot theta and del over del phi. This term is for the x component. Then we are taking the j component, and if we write it minus IH cross, the first term is cos phi, then there is del over del theta from here. Then from here we can get cos phi, cos theta sin phi, there is sin theta, so there is minus sin phi, and again it's cos by sin is cot theta, del by del phi. This is the y term. Similarly, we can write the z term, which will be, so there is no k, there is no k, the k is minus sin theta, the sin theta will be cancelled out, minus minus, it's plus, so simply del over del phi will be there, so it's minus IH cross del over del phi. So the component x, y and z of angular momentum has been written in theta and phi coordinates. Now we can use these terms to get the square of angular momentum operator. So we are going to do something with these and get the square of angular momentum operator. So we know that we are going to define two operators. First is the raising operator, raising operator. One of the letter operator, so it's L plus, which is Lx plus I iota Ly. So I'm going to use these terms. So the raising operator L plus can be written as IH cross plus iota Ly. There will be minus iota square is minus 1, so it will become plus H cross. So H cross will come out and I will go inside this. So H cross is common. From here the term will be I sin of phi del over del theta plus I cos of phi cot of theta del over del phi. So I has gone inside, the H cross has come out, the I is minus 1, minus minus is plus. So this term will be there. So next term will be plus cos of phi del over del theta minus sin of phi cot of theta del over del phi. So we can rearrange and get something good from here. So it's H cross. So we can take del or del theta out. This will be iota sin phi from here, cos phi from here. So it becomes cos phi plus iota sin phi, and this will be del over del theta. Now from here we can see that we can take the cot theta out, plus cot theta is out. Now from here we can write iota cos phi, and here it is minus sin phi del over del phi. So this is the term. This is the term, right? So we can do something here. We can take the I out of this equation. So if I take I out of this, so I will be here. I will go from here. It will come here. So I can multiply and divide by I. So this will be I square, and there will be I on with sin phi. So I square is minus 1. So it's minus minus is plus 1. And we have a I over here. So this becomes e power I phi. This becomes e power I phi. This can be taken out, and L plus can be written as H cross e power I phi. And this is del over del theta plus I cot theta del over del phi. This is the raising operator. Similarly, we can write down the L minus. The lowering operator is H cross e power minus I phi. In a similar fashion, we can write L minus, which will be defined as L minus is Lx minus iota Ly. So this will be minus del by del theta and plus I cot of theta del over del phi. So we are going to use these two terms to get L square. So our target is to get the square operator here. So nice and good. Now we are going to use these two terms. So what we are going to do is now L plus L minus. So we are trying to get L plus L minus. Let's see what we get for this. So L plus is H cross EI phi, and it is del over del theta plus I cot theta del over del phi, and L minus is H cross. So I'm taking H cross out here, so it's constant H square e power minus I phi, and it's minus del over del theta plus I cot of theta del over del phi. So we are going to solve this thing. So this is pretty bad, there will be a lot of terms here, so we can get it. L plus L minus is H square e power I phi. So I'm going to start with this operator. Let's move this operator through this to this. So del by del theta e power minus I phi can be taken out. So e power minus I phi is out, and this will operate on this. So del over del theta minus del over del theta, there will be a minus out here, and it will be del 2 over del theta square. So this thing is done with this. Now this thing goes into this. So e power minus I phi again can be taken out, e power minus I phi, and this will go here. So I is there. Now del over del theta, there are two terms, so it will operate on cot theta first. So del over del theta, cot theta is minus cosec square theta, minus cosec square theta. So there will be a minus. Now we can write del over del phi. Again, this operator will go because we are using chain rule here. We have written the term for this cot theta. Now we are going to operate this on del over del phi. So again, e power minus I phi can be written minus I phi, and here it is I cot theta. This time we are taking I cot theta here. Now this is going to operate on this. So del theta and del over del phi is del 2 over del theta del phi. So we are done with this operator. Now we are going to operate this thing on this through this. So I can write I cot theta, so it's plus I cot of theta. So this operates first on this and then on this. So e power minus I phi is e power minus I phi. There will be a minus I outside. So minus I is I square is minus 1. So this thing will become plus cot theta e power minus phi. And then there is minus del over del theta. So minus del over del theta. So this operator has been operated on this. Now this will be operated on this thing. Okay. So again, plus I cot of theta, and we can take e power minus I phi here, and it is operated on this. So there will be a minus sign out. So minus of del 2 over del phi del theta. Okay. Now we are done up to this term. So now we are going to operate this thing on this through this. So let's start. Let's operate this on this first. So it's plus I cot theta, and when del over del phi goes on e power minus I phi, so it will be e power minus I phi. There will be minus I outside. So minus I, so minus I square. This will become plus. So we can remove the I from here, and there is del over del phi here. So del over Yes, so it's a del phi, so we can take the I cot theta outside, all right? So I cot theta can be taken outside, so there will be I, then there is a cot square theta, and there is del over del phi, correct? Now, again, this is going to operate on this thing, okay? So it will become plus I cot of theta, all right? So e power minus I phi we have taken out, e power minus I phi is here, right? Now, I cot theta we can take out, I cot theta, so it will become cot square theta. I, if we take out, it will become I square, which will become minus 1. So this is minus cot square theta minus I phi, and this is going to operate on this thing. So this will become del 2 over del phi square. So there are 1, 2, 3, 4, 5, 6, 7 terms. Pretty bad, yeah? All right, now what we are going to do is to rearrange these terms to get something nice and beautiful. So as we can see here, these two terms are exactly similar. This is plus, this is minus, so these will be cancelled out. So we have something, you know, at least the two big things are gone. Great. So again, if you see here, e power minus I phi, 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 e power minus I phi. So e power minus I phi comes out and it goes with e power I phi, and this becomes 1. So I can write L plus L minus is h square, and I'm taking, so e minus phi, e phi is 1, and I'm taking minus out of these whole terms. So the minus is gone. This is del 2 over del theta square, del 2 over del theta square, right? Now, minus we have taken out, so it will become plus I cosec square theta del over del phi, great. And if we take minus out, this term there will be a minus, so it will become minus of I cot square theta del over del phi. Now we have left with these two terms. This, if you have taken minus out, these two will become positive terms. So the next term is plus cot of theta del over del theta, and this term is plus cot square theta del 2 over del phi square. So we have this nice equation here from here. Now we can rearrange some of these. So we can write L plus L minus S minus H square del 2 over del theta square, and if we take I out of this and del over del phi out of this, this will become cosec square minus cot square, which is 1, beautiful 1. So this will become plus I del over del phi, which is a relief to us. This whole term has been converted into this. Now this can be written as plus cot of theta del over del theta plus cot square theta del 2 over del phi square. So we have this term here for L plus L minus. Similarly, we can see, write L minus L plus, which will turn out to be minus H square del 2 over del theta square. Similarly, there will be just a difference of minus iota here, del over del phi plus cot of theta del over del theta plus cot square theta del 2 over del phi square. So these two equations are very important for us to derive the L square operator. So now we can write L operator square, the big guy which we are looking for, can be written as half of L plus L minus plus L minus L plus. So we can see that this is Lx plus iota ly, this is lx minus iota ly, this will become lx square minus iota square ly square, which is lx square plus ly square. This is lx square plus ly square. So this is 2 of lx square plus ly square. So I divided it by 2, and then we have to write lz square as well, because this term will turn out to be lx square plus ly square. So this is lz square. Now we can write this term here. So L square is 1 by 2. So we can directly see that these terms are exactly the same, just a difference of minus iota here. So if we add these two terms, there will be a factor of 2 with each of these terms, and we have divided it by 2, so this factor will cancel out, and this term will be vanished because this is plus and this is of minus with the same values, so this will be cancelled out. So this can be written as h minus h square, and there is del 2 over del theta square, plus this has been cancelled, so cot theta del over del theta plus cot square theta del 2 over del phi square, and we have left with lz square. We know that lz, we have derived lz, and we just derived it. It was minus ih cross del over del phi. So the square of this would be minus ih, it's plus h square into iota square, which will become minus h square del 2 over del phi square. So for lz square, we can write minus h square del 2 over del phi square. Now L square is minus h square. I have taken minus h square common from here as well. So this term will be coming with this. So this become del 2 over del theta square plus cot of theta del over del theta plus cot square theta del 2 over del phi square. Minus h square has come out, so there will be plus del 2 over del phi square here. Nice term, we have a nice term here, see. So what can we do now? So L square is minus h square del 2 over del theta square plus cot of theta del over del theta, and if we take del 2 over del phi square out, there will be 1 plus cot square theta, which will become cosec square theta. So it's cosec square theta del 2 over del phi square. So with relief here, we have nice 3 terms for del operator square term. So this can be further written as L square is minus h square del 2 over del theta square plus cos of theta by sine of theta. Cot theta can be written as cos theta over sine theta del by del theta plus 1 over sine square theta. Cosec square theta is 1 over sine square theta del 2 over del phi square. So this is the final term. So we are getting to the big guy. It's minus h square, and this term, these two terms can be written as 1 over sine theta. The standard form is this, del over del theta sine theta del over del theta. If we solve this, we can solve it. So this operator first goes on sine theta, so this will become cos theta del over del theta. So cos by sine is cot theta del over del theta, this terms. Then this goes to this, sine will come out, sine will be cancelled out, and it's del 2 over del theta square. So this term is equivalent to these two terms, right? And plus 1 by sine square theta del 2 over del phi square. This is our standard form for the square operator. Very important, very frequent.